I'm not convinced that VDI is the same thing, but I definitely think it's got promise. I think that it definitely has the promise to perhaps allow us to create, more reliable systems, and it's just through all that different, I think, methodology of abstraction. All right, so ADD done. So we also think this is kind of cool too. A lot of us have a pretty good idea of how many users and how many systems, and we probably have some great application inventory software that tells us, what versions out there and stuff like that. We wanted to play around with, well, what else would you want to see, from machine age or applications or users or even user groups. Anything in our software, you can filter it by, a user group or a username or anything like that, which is pretty cool. You can see here, we used to laugh about how much servers were underutilized. This is a small little environment, but the 50 gigahertz of processor I have, over the last 60 minutes, we've used 1 gigahertz of processing power. I mean, these rascals, when they're really bad, they're really bad, but when users are up getting coffee, it's not much CPU utilization that's going on. Same thing with memory. I get this question all the time, like, how many virtual desktops can I get per core? And it's like, well, it depends. It depends on a lot of things. But most importantly, it depends on what your users are actually up to. And it's not kind of the same thing with memory. When you think about some of the memory page sharing that ESX can do, and now Microsoft recently announced, I think on the 18th or something of last month, that's interesting because if I actually had visibility into what users were using what apps at what time, and I could congregate them on like hosts, then I'm going to have a lot hotter memory pages than if I just let them all kind of do random stuff. And maybe not completely appropriate for smaller deployments, but it certainly is a fun thing to play around with and increases density and lowers capex, when you get going. So those are the kinds of things we put in. But we also wanted to look at what happens across the network, not just the virtual channel or the remote display protocol from a virtual machine out to an endpoint, thin client or repurposed PC, but how does that virtual desktop communicate with other, application servers or cloud services that are out there in the environment? So this is pretty cool because we built in the ability to set like allowed and disallowed traffic or different alerts and thresholds, like following user groups are not allowed to attempt to hit the following URL or the following network resource or something like that. So we thought that was kind of cool. Storage is my favorite. This is pretty fun because you basically can now look at the aggregate I/O, the read rate, the write rate, the transfer rate of what your users are doing to their local hard drives today, and have a very, representative picture of what the activity is going to look like once you get it into the data center. I think fable of VDI is that users magically do something different just because you change the hardware on which they're executing. They still come in at 9 and they double-click, Facebook and do their updates or whatever that is. My daughter tells me I need to be on Facebook, but whatever. Actually, I have an account. Josh, you found me on Facebook. You're my first stalker. I like it. But I don't have any others, unfortunately. But the cool thing is that if I can take that I/O activity, if I can take what users actually do to their physical hard drives today. Now, the hardware that you're going to put them on when you get them into the data center is not a $20 Seagate or Western Digital hard drive. It's slightly more expensive IBM or EMC storage, for the most part, and so things count. So we actually are able to now look at different storage pools and say, okay, let me look at the activity of that storage pool over time. And when I see a peak or a valley, either in read or write, or even latency or disk queue length, let me pick on that bubble and drill down and see who are my offending users. But let's do something even more fun. Let's look at not just the offending users, but let's drill down and see what applications or system processes were running on their machines when they were offending. And sometimes you'd be amazed at what you'll see. It might be, Adobe Acrobat Updater or, TweetDeck or whatever it is. Maybe it helps us, create or do things in an interesting way. Oh, this is cool. This is kind of new. I keep saying this is cool a lot. I think it's cool. One of the things that we get asked a lot is, well, which ones of my applications are virtualizable? I'm not even sure if that's a word, but it should be. And we said, well, it depends. And we started thinking about what it depends on. And so we started thinking about, okay, well, let's look at the relative size on disk of that application. Let's look and see if that application, well, let's see how many users are using it and have it installed. But then let's look at, does it install device drivers? Does it rely on system services? And let's do that kind of good, better, best scorecard for applications. And we don't make any decision on which application virtualization solution you might want to use. Different ones are more appropriate for, I think, different use cases. But it definitely is compelling when you start thinking about when and if you are going to change operating systems. I think, personally, one of the things that challenges a lot of migrations isn't so much getting the flat files and the data over there. It's having a level of understanding about which applications are going to break. When I get over to the new operating system, or if I go 32 to 64-bit. So this was just one of the screenshots I wanted to show you. Now let's see what else. How much time do I have? I feel like I've been...
Time one.
Cool. Another thing that's kind of interesting is that we want to have intelligence, whether it's a physical machine or a virtual machine, into both the configurations, but then we want to be able to alert on change control. So if a user downloads an app, if a user tries to change a setting, if a user does anything that we don't want them to do, maybe we're in a world where we don't lock down desktops, we thought that would be pretty important to give you visibility on. So I know this is really small. It's obviously a lot clearer when you log in. But things like, which different user accounts have logged in and out of the machine. What was the login delay for each one of those? What was the CPU user queue length, context switching? How efficiently is that user using their either physical or virtual CPU? And up in the corner, we have screens and resolutions and how many disk drives they're attached to and which printers and all that kind of fun stuff. But then we start looking a little bit at the network-based metrics, the storage-based metrics. But this is the fun one down here, which is all of the top applications. And you can filter these out so that, nominal system processes. Yeah.
When you say which PC or which user has installed which application, we have shared PCs. Like when you capture the data of who was during the login, who installed this malware.
Yeah, sure. Because what we're doing so with connector ID, how we're doing that is. Probably should have explained the patents. So when we're going ahead and doing our packet stamping, I talked about the agent, and it's either a full-fledged agent or a virtual agent. Just streams some code into memory when a user logs on, but it's the same thing. But basically what it does is it puts a thumbprint in that packet that says it was Tyler, and it was Tyler at this time from this machine. But it could also say it was Tyler from a different machine. So it allows me to basically now track irrefutably. There's about 14. We wrote a white paper on it. It's pretty interesting. That talks about the different 14 methods that we'll use to do that kind of ACK-SYNACK handshake between that packet and the hub and say, okay, I'm going to call with 99.99% certainty that it was Tyler. So the interesting thing is if you do have users that walk around to different kiosk machines, we can either track the activity of just that chassis, meaning that machine and all the different users, or you could simply look at a different report, look at Tyler as he transgresses different machines in the environment. VDI is going to bring up a lot more of that, we think, just because the theory would be any device, any place, any time, I log in or smart card in and I get my desktop up. So it'll be more migratory, I think, the theory is. That's a really good point. Yeah, so there's kind of like 3 ways to get data out of our product, at least. The first is the GUI, and I'm just showing you some screenshots here, which are pretty valuable. The second is through the 200 reports that we wrote. But the third, and maybe the coolest, is your ability to write custom reports and alerts and RSS feeds based on anything that you want to see, when you want to see it, if you want to see it. So that tends to be pretty interesting as well. I'm a simple guy, so I told them to give me pretty colors when they were writing the code. I'm like, give me green, give me yellow, give me red. Green means good, yellow means maybe, and red means really bad. Doesn't mean I can't necessarily virtualize a workload that shows up as a bad fitting desktop, but it means there's either a technical risk or a financial risk or a user experience risk, meaning that trying to put a user who consistently shows as having 600 to 900 milliseconds of latency between where they are and where I'm measuring from is probably going to be a bad thing. I can do it, but they're not going to be happy. So I guess that's kind of the tracking there. And I know I've only got a couple more seconds. So in the future, this is actually shipping with our platform now, but it's something to play around with because we built in some intelligence to say, well, don't take our waiting for it. When we come up with that composite metric, this is what we think the showstoppers are. But we also built it with some of the more popular protocols, application, delivery methods, storage fabrics, different provisioning and I/O optimization stuff that's out there, so that you can basically, I guess, play with that composite metric to lay it over different possible solutions. These are primarily software solutions that deal almost entirely up at the OS and above level. But the cool thing is that we're doing a lot of experimentation on some things that might actually not take away some of the power of the gray matter, but make logical paths seem a little more illuminated. I guess that's probably the right way to say it. But yeah, right now we're completely independent. We didn't, like Josh, like AppSense, we haven't taken any venture capital. We roll quarters and we have to make payroll. We got 40 people working, so.